The conference has been unmuted.
This one?
Yes.
Oh, the form?
Yeah, you
Bridge
have
is
a
now
question?
open. Do we have any questions?
So is it all clear now? Or do we want more explanation? Any new question or a follow-up? Okay, looks like we... yes, please. Okay, and then it will send the response. So if there is no response, the UE will indeed increase the power. So if there is something strong enough, then the base station will be able to detect that, because it is trying to match the received signal with all 64 possibilities. Any other follow-up question or anything else?
Yes, actually follow up for this answer, the last one.
Okay.
No, my question was, it will look at a certain subframe, but does the eNode B look at each subframe coming to it, looking for match?
Exactly
everything?
right.
But it has to be a P-ratch?
Yeah, P-ratch, yes.
Only for P-ratch.
Yeah, only for P-ratch.
So it will detect first that this is a P-ratch, and then it will try to match it.
Yeah, because, okay, yeah, let me give you more information. Okay, so let's say this is one subframe. Now I'm showing you uplink, okay? Uplink. We are discussing FTD, now this is uplink. Now the base station would have reserved some resources for the random access channel. Maybe here, let's actually we have some control channels. So let's say here. This is what the eNode V has reserved for random access channel, reserved by eNode V. So every UE knows that these 6 resource blocks, let's say 0, 1, 2, or whatever, up to 49, out of the 50 resource blocks, these carry the random access channel. And now, the base station is looking at these 6 resource blocks in every subframe. Okay, and then it will find a match whenever someone is sending a strong enough signal on those random access channel resource blocks. Does that make sense?
Yes, thank you very much.
Okay, sure. Okay. Okay, anything else before we go to the next slide? The best way to customize this course for you is to ask questions. That will ensure that we meet your requirements. So please keep sending your questions. And this audio bridge is one more approach that you can take to ask questions. So any other question? If you do not like to type, you want to talk, go ahead. Anything else? We'll give you 30 seconds. No question for 30 seconds. Then we resume with the presentation. The clock is ticking. Okay. So Eric, let's mute the bridge, but please
The
continue
conference has
asking
been muted.
questions. Live meeting. Okay. Moving forward. We know all about the RRC correction now. And as part of this setup, we have already conveyed the attach request message to the core network. Okay. Now our node B has received this RRC connection message from the UE, and there is a non-access data message included inside that. So since it is a non-access data, we need to forward that to some MME. So it's possible that our E node B is connected to multiple MMEs. So in that case, it will have to pick one of the MMEs. So E node B selects the MME. The selection of the MME is done by the E node B. Okay. One of the important feature is called load balancing. Okay, load balancing. So basically, we want to make sure that if we have, let's say, these three MMEs here, 1, 2, and 3, we are not unnecessarily overloading one MME, and we want to share the load among all these MMEs. So the E node B will pick, let's say, MME number 2. And when it chooses that, we have tried to balance the load. Okay. That is one of the important features. Okay. And that will make sure that we are utilizing the MMEs properly. Okay, that is the basic. But in summary, E node B will select one of the MMEs primarily to balance the load among the MMEs. So let's say that we picked this specific MME, and we will forward the attach request message, which is part of that NAS dedicated information, which was part of the RRC message. Okay. And what kind of information do we have? For example, it would indicate its identity. So it could include the IMSI, International Mobile Subscriber ID, or if it has a valid ID called GUTI, Globally Unique Temporary ID. Sorry about the flurry of acronyms, but we can not avoid them. So we have Globally Unique Temporary ID. And this is given to the UE by some MME in the past. So it is possible that we have some valid GUTI. Then we will send that. If we do not have any valid core network ID like GUTI, then we will just go ahead and send IMSI. So one of these kind of IDs will be sent. Because whenever we are sending a message to the core network, we need to identify who we are. So this kind of GUTI and IMSI would identify ourselves to the core network. We also mentioned what kind of algorithms we support, security, encryption, and so on. Do we like to get IPv4, IPv6 address, or what? Which PLMN we have selected? Why we are sending this attach? Maybe it is after power on, so it will be initial. If the terminal wants to use the DHCP approach to get the IP address, it would indicate that as part of protocol configuration option. So now this information goes to the MME. Okay. And MME could either get this IMSI directly from the UE, or it can get it from the old MME that has given this GUTI to the user. So it depends. But basically MME can get IMSI without any problem. So we have IMSI. We will have to now process the attach request message. Okay. So one of the important things we need to do as part of attach is to make sure that this is a valid user. So that's why we carry out the authentication process. In LT, we rely on the authentication and key agreement process. And the overall authentication is similar to what we have been using in previous releases of UMTS. Okay. And our release 19 was the first release of UMTS. So we are basically using similar authentication algorithm. Okay, so here is the basic idea. The MME will send authentication data request to the HSS. It will say, oh, here is the IMSI of the subscriber, and I want to authenticate that user. HSS will generate random number, and then there is some authentication algorithm. That algorithm will have random number as the input, and there will be some secret key stored for that user, for that IMSI, and the random number and secret key together will generate several parameters. Okay. Expected response, then ciphering key, integrity protection key, authentication token, etc. So we generate those numbers. Okay. So you can see that we have total of 5 parameters, right? Random number and the other 4 generated by the authentication algorithm. So that's why we call them quintet. 5 pieces of information, quintets. We will provide that to MME. The MME will send the random number and the authentication token. So out of those 5 parameters, we are sending a random number and the authentication token. Now the UE will use the secret key that it has and it will also use this random number, and the authentication algorithm will generate the parameter, let's say response, the token, and then it will compare that with what the network is telling. So if there is a match, it means that the UE is talking to a valid network. So first, the UE is authenticating the network, and based on authentication token. So UE is satisfied that it is not talking to some fake network, so it can trust that network now. And it will forward this response to the network now. So as part of the authentication response, we are sending that RES to the MME response. Our MME will match response coming from the UE with the response it got from the HSS. If both of these match, then we know that this is a valid UE. So now the MME is authenticating the user equipment. So as you can see, we have mutual authentication. Right? So UE authenticates the MME, MME authenticates the UE. Okay. And then UE also calculates these keys, ciphering and integrity protection keys, so that we can use those keys to secure the air interface. A ciphering key is used for encryption. So you can encrypt your signaling messages, you can encrypt your actual user traffic, email, web page, etc. An integrity protection key is basically trying to make sure that the sender is valid. So validity of the sender can be confirmed by using the integrity protection. Okay, so those are the main topics related to authentication. Okay. We also need to make sure that we are offering the subscriber the service that it has subscribed to. So that's why MME will contact the HSS. It says, okay, I'm responsible for the UE that has this IMSI, and please give me the profile for that subscriber. So HSS will provide the information. For example, what kind of access point names the user should be allowed to access. So for example, it may be AT&T.com or VerizonWireless.com or BlackBerry.net or whatever. So the access point names that the user can access. Okay. And there will be specific PGWs. PGW, maybe one PGW handles att.com and the PGW handles BlackBerry.net and so on. Now we have a question that 5 parameters are generated but why less than 5? Oh, actually we used all of them, right? So for the authentication, for authentication alone, we use authentication token, we use random number, and we used expected response, right? So we used 3 parameters, right, for authentication itself. The other 2 parameters, CK and IK, ciphering key and integrity key, we will use those later when we want to do integrity protection for signaling messages, when we want to encrypt the actual traffic. So we will use all 5. Only during the authentication we are using 3. The other 2 we will use, but little later. Okay. So hopefully that makes sense. We are indeed using all the 5 parameters, okay, but not at this time. Ciphering and integrity keys are generated, but they are used later, not at this time, but they will be used. Okay. Anytime the questions are not answered satisfactorily, please ask a follow-up question. Okay, we want to make sure that you get what you had in your mind. Okay. Okay. So we got information about the subscribers, and in that process HSS knows that okay, this specific MME is responsible for the UE, okay, responsible for this. So if we have to send let's say a page message or whatever, then MME will be contacted that we have to send a page to this UI, and then MME will send a page message to all the E node Bs in a specific geographical area. Okay, okay, so we have a follow-up question. Oh, I see. So we mentioned that, oh, I see. So let's go back. Okay, so I gave you an example of just one authentication vector, meaning I generated one authentication vector that had 5 parameters: random number, expected response. Let me just use this highlighter. So one authentication vector I generated, and I'm using those 5 parameters. Okay, but it is possible that we can generate multiple vectors. Okay, so I can have multiple random numbers, for example. Okay, and then I will generate the other responses, and then we will pick one of the vectors to start with, and another vector maybe we will use in future. So that's why we can be. So in terms of how many vectors, there could be multiple vectors, but for each vector there are 5 parameters. Okay, 5 parameters. Okay, so hopefully now this is clear. I gave an example for one vector, and one authentication vector has 5 parameters. But we could generate such sets of parameters. So I can have maybe 3 authentication parameters. Okay. So okay, yeah, so now it is clear. Okay, good. Okay. So we talked about this. So what happened? Our enemy processed the attached request, and then we carried out authentication, mutual authentication to be more specific. Now we want to set up a dedicated, not dedicated, it's called default bearer. We want to set up a default bearer between the UE and the edge of the network. So here is our UE. We want to have end-to-end link that goes all the way to PGW, because this is a gateway to the outside world. So within our LTE network, right, we want to have end-to-end connectivity. So this would be our default EPS bearer. EPS, Evolved Packet System. Evolved Packet System. So it includes the radio network, EUTRAN, and it includes the core network, EPC, Evolved Packet Core. Both the radio and the core network are part of the EPS. So we are trying to establish the default EPS bearer so that we can provide always on connectivity. Okay? Always on connectivity. It means that we have to establish several logical links between UE and E node B, E node B and the serving gateway, and then between serving gateway and PDN gateway, PGW. Okay. Only after you have all these connections, here, and here, only then we have the end-to-end EPS bearer. So our enemy needs to now pick some SGW and some PGW. Okay. So who does that selection? MME does that. Always remember that MME will be selecting the serving gateway, and MME will also be selecting the PGW to establish this default bearer. Now, this default bearer will help us exchange user traffic. Since we have the just default bearer, we cannot do some super duper quality of service. So voice or IP we cannot do, because voice or IP will need strict QoS control. But some service, let's say email kind of service, where we are running that in the background and where we do not need strict timing control, strict data rate control, then we can use the default bearer. We will be able to do the basic user traffic exchange. Okay. But if you really want excellent quality of service, you need another kind of bearer called dedicated bearer. But at least if you have default bearer, you can do data activity without any problem. The basic service you will get. Okay. So in summary, to get this always on connectivity for user traffic, we will establish default bearer, and since default bearer involves the logical links across the UE, eNode V, eNode V, SGW, PGW, we need to pick some SGW and some PGW for our bearer, and that is the responsibility of MME. Now, how could MME select, let's say, PGW? Now, normally, we have two options. It is possible that the MME will just use the subscriber information from the HSS. So there will be some default APN, access point name, such as verizonwireless.com, and then associated with that APN there will be some PGW, let's say PGW number 2. Okay. So then MME will pick PGW number 2. Okay. It's possible that the UE provides some access point name, and then based on that access point name, MME will choose PGW. But in any case, MME will select a suitable PGW for that UE. How do we select serving gateway? Again, MME will do the selection, and that is primarily based on topology. Okay. So, for example, if this is Washington DC area, maybe that is controlled by serving gateway number 200. Then we have Los Angeles, that is controlled by serving gateway number 300. We have Dallas, where we are located. Maybe that is controlled by serving gateway number 500, and so on. Okay. So basically, we will pick the serving gateway based on the geographical location, wherever the user is. But in summary, it is the MME that selects both serving gateway and PGW. Okay, time for me to ask you a question. So I will give you a couple of minutes so that you can work on this. And we appreciate your participation, so please participate in the polls. Your degree of participation will decide how much raise you will get. So it is in your interest to maximize your participation. Okay, in the meantime, we have this other question. Is MME also doing the load balancing, or is it strictly location based? In general, it is possible to do some sort of load balancing, but primarily in practice it will be based on the location. The standard does allow you to have multiple serving gateways controlling a given area. It's called some pool area. We have serving gateway pool area. But as far as practical deployments are concerned, I think we would have one serving gateway for one area, another serving gateway, another area. That makes more sense to me. But standard does allow us to carry out load balancing. Good question. I will give you maybe one more minute. So think of this serving gateway like your PDSN. So one geographical area, right, will be controlled by one PDSN or foreign agent, another geographical area, another PDSN foreign agent. If you are familiar with the UMTS, then it is like SDSN. Right? One area, routing area controlled by one SDSN, another routing area controlled by another SDSN, something like that. Okay. Okay. So it looks like some of you are still working, huh? I will give you maybe one more minute. So please participate in the poll. Oh, yeah, about the raise, please do not come after me. I was just joking, right? Your participation does not affect your raise, but we do appreciate you participating in all the polls. When I looked at these numbers, out of how many students? About 30 students. I got only 17 responses. So I wanted to make sure that you are awake and well, and you are participating actively. We want to make sure. So please participate. Yeah, my begging does have some effect, and we have our numbers increasing slightly. Okay, let's move forward. So basically, the first one is the correct answer. So both the serving gateway and the PGW are selected by the MME. Okay. Now this bearer, as I mentioned, whenever we have bearer is the link between UE and the E node B, SGW, and PGW. Okay. Between UE and E node B, we have radio bearer. Between E node B and SGW, we have S1 interface. So that is S1 user plane. That is the S1 bearer there. And of course, between the SGW and PGW, we have the S5 bearer. So together, the radio plus S1 plus S5, they will give you EPS bearer. Okay. And if you want to have different quality of service, you need to have different bearers. So for example, I have some service, maybe service 1 and 2, maybe email and web browsing, but I do not want to differentiate between these two services based on QoS. I want to give both the services same quality of service. So then I can put both of them on the same bearer. However, I have another application, another service number 3, and here I have voice or IP. So I need strict latency control, and I have to reserve data for that. So voice over IP, since I need the QoS label that is different from what bearer 1 can give, I have to establish a new bearer. So always remember, anytime you want to provide different quality of service, you must have different EPS bearer. Okay. Can we just have only two QCIs? No. One UI can have many QCIs. There are up to 9 QCIs. So no, that's not a problem. I'm just giving you one example that we have two bearers with two different levels of QoS, but not necessary that we have only two. We could have multiple. Okay. Thanks for your question. Okay. Now there is so-called TFT, Traffic Flow Template. And the main idea behind Traffic Flow Template is the following. Let's say there is some incoming IP packet. Our format has separated G, but it's incoming IP packet. And now the PGW needs to figure out, should I put it on this bearer? Should I put the packet on this bearer or this bearer? Where should I put that incoming IP packet? And the answer to that question will be provided by Traffic Flow Template. The Traffic Flow Template tells us where to place an incoming IP packet. So in this example, our UE1 has two bearers. Service data flow 1 and 2, both of them have the same QoS level. So we are putting both the services on one bearer. However, another data flow, okay, 1, 2, let's call it 3. Service data flow number 3. We want another kind of quality of service, QoS level 2. So that's why we are establishing a different bearer. So we have two EPS bearers for one UE, and then for another UE we have another bearer. So our traffic flow template will help us figure out that, okay, this packet, maybe it should go to bearer number 2. So let's see how to implement so-called traffic flow template. The idea is very simple. We just have a simple database, okay? And that traffic flow template database may look like this. We have one UE number 1, and that UE has some IP address. There are 4 different service data flows. Video has these 2, then third service data flow here, that is voice over IP, another service data flow, that's your default, and we have service data flow 1 and 2 going over bearer number 1. Similarly, we have service flow data, let's say 3, that is voice over IP, and that goes over bearer number 2, and so on. So let's say a voice over IP packet comes in, and it has destination IP address for UE1. Then we know, oh, okay, so we need to take a look at this, okay? But now we have many bearers, right? Bearer 1, bearer 2, bearer 3. So where should we place that packet? Bearer 1, bearer 2 or bearer 3. We need some additional information. So we can use the port numbers. So we say, oh, this port number matches the port number for voice or IP. So let me forward the packet to bearer number 2. So now the incoming packet, that is voice or IP, based on the port number and destination IP address, we are able to make a decision that that packet should go to bearer number 2. So in summary, traffic flow template helps us figure out which EPS bearer should be carrying the incoming IP packet. Just a data. Okay. So we, as an MME, have picked SGW and PGW, and we want to establish the default bearer. So here is the signal that will take care of the bearer. The MME will tell the serving gateway that, okay, let's establish bearer number 1. Okay. And we will tell the user, we'll tell the gateway that please contact this PGW. So this is the IP address of the PGW because MME has selected both SGW and PGW. So we provide PGW IP address to the serving gateway also. We will say that this user requires IPv4 type address, and this is what we want to provide, this kind of quality of service, some default quality of service. Serving gateway looks at the PGW IP address, says, okay, let me contact that PGW. So it will send a bearer request message to the PGW. And since we need to establish this tunnel as 5 bearer, we need to identify the endpoints of the tunnel. So tunnel endpoint ID here, tunnel endpoint ID here. So SGW is responsible for each part of the tunnel, and the tunnel will carry the packets in future for the default bearer. So that's why we are giving that tunnel endpoint ID. Okay. And the bearer number that we are trying to establish. And we will say that, oh, this user needs some IPv4 address. And this is the QoS we want to provide. PGW says, okay, no problem. It will send the response that, okay, I'm fine with the bearer number 1, and you can use this specific IP address for the user plane, and here is my side of the tunnel. See? So in the previous diagram, we took care of serving gateway side of the tunnel, and now when you have the PGW terminal endpoints, then we have established both sides of the tunnel. So this is this side of the tunnel, tunnel endpoint ID Y, tunnel endpoint ID X from the serving gateway. And since we have made a request for an IP address, PGW says here is the IP address for the UE. So if we want to establish if we want to allocate the IP address during the default bearer setup, then PGW will just provide the IP address in this fashion. Okay. And then serving gateway is just responding to the original MME request. And this is the IP address that we have reserved for the UE. And what else? Yeah, we need to now have this need for S1 bearer. So this is another tunnel. Now we need to give this tunnel endpoint ID. That is here. Okay. And the IP address of the serving it. So we are just giving that to the MME. The MME will then contact the base station, E node B, and since earlier the UE had sent out attach request, we are sending the attach accept in response to that original message from the UE. And this is the PDN address that we are allocating, IP address for the UE. We allocate an ID to the UE. So every MME will give a unique ID to the user, unique UE ID. Now, IMSI, International Mobile Subscriber ID, is the original ID of the UE. And in UMTS, we want to minimize the use of our original ID. So, in UMTS Evolution LTE, we said, okay, let's do the same approach here in LTE. So, instead of using IMSI to identify the UE, let's use another temporary ID called STIMSI. And this is a short form of GUT. So once the UE receives the attach accept message containing GUTI, it knows what STIMSI it corresponds. It's just a short form of GUTI. Okay, and okay, and we also provide the serving gateway information to the E node B so that we can establish a tunnel between E node B and the serving gateway. Okay, so now our E node B will send the RSA reconfiguration message that contains the attach accept message. The UE responds with the complete message, and we have another message called uplink information transfer that would contain attach complete message. So that means that we have successfully established this bearer number 1, EPS bearer 1, the default bearer. So we have the radio bearer taken care of between UE and the E node B, but we have not yet established the tunnel between E node B and SGW. So if you remember, we have given the serving gateway side, right? We have given this part of the tunnel, this end, but we have not yet taken care of the other end of the tunnel. So that should happen now. Okay. So E node B is telling the MME that, okay, let me give you my side of the tunnel. Okay, and now we have both the sides of the tunnel established for the S1 user name. Bearer request that will contain that information and bearer ID. So E node B and SGW do not directly communicate with each other, right? They rely upon the MME. MME will handle the communication between E node B and the SGW. So So for signaling, MME is the main entity from the core network perspective. So now we have established end-to-end error. We have the radio error between UE and E node B. Between E node B, SGW, we have S1 error. And finally, SGW, PGW, we have S5 error. Time for a question. So during this overall attach that we discussed so far, okay, what could we potentially do? Okay. Can we do authentication? Can we allocate IP address? Can we set up a default bearer? Pick the best possible answer. What did we discuss so far? Did we discuss all these three steps? Did we authenticate the UE? Did PGW allocate an IP address? Did we establish a default bearer? If the answer to those questions is yes, then you know what the answer should be. So whatever we discussed so far in the session was first RFC connection setup and then the attach operation. So as part of the attach, what did we discuss? That will give you the hint to the question. I will give you maybe 1 more minute. And please participate in the poll. Very easy. Think and click. Should take you 5 seconds. Maybe a couple of minutes to think, but clicking itself should not take you a long time. So please participate. Thirty seconds to go. Okay, let's share with you the results. Very good, 90%, 95% accuracy, very good. So we can do authentication, we can allocate IP address, we also establish default bearer. We can do all of those during the attach operation. Thank you for participation. Okay, let's move forward. Now allocating an IP address. So basically we have two options. We can give the IP address during the default bearer activation, or we can do that after we do the default bearer activation. Now what we discussed was here, as part of the default bearer activation itself, PGW allocated an IP address to the UE. That's what we discussed. But it is not mandatory that we have to do that. Okay. So another option is, let's establish the default bearer first, and after that is done, then we will take care of the IP address allocation. So you can have these two approaches. We can give static IP address, we can give dynamic IP address, anything is okay. Static means that same IP address all the time. So whenever UE needs an IP address, we give the same IP address. So that is called static IP address. So basically we have reserved some IP address for that UE. Dynamic IP address means that whenever there is a need, we give the IP address to the UE. If the user is not using the IP address for a long time, we take away the IP address and give the same IP address to some other UE who may be doing some data transfer. So dynamic IP addresses are given to the user, taken away by the network. Okay. And of course, dynamic is more popular these days because if you start allocating IP addresses in a static fashion, we will run out. However, we do support both. In the LTE standard, we have support for both the static IP address and dynamic. Both are supported. Not only that, we can give IPv4 address, IPv6 address, and we even support dual stack IPv4, IPv6. So very, very flexible. We are not stuck to a specific kind of IP address. Okay? So we support, in summary, we support both IPv4 and IPv6. Nothing is mandatory. Essentially, it is up to the service operator. AT&T, Verizon Wireless, they will decide what they want to support in the network. Okay. We looked at the scenario where the IP address is allocated as part of the default bearer activation. Okay. So basically, we had sent out attach request message, and in response to that, the MME is sending this attach accept message. And as part of that attach accept message that MME sends, we have inside that IP address for the user, and that IP address is allocated by PGW. That's what we discussed. Okay. So we can do that during the default bearer activation. Now, PGW may have a pool of IP addresses, right? And then it can use one of the addresses inside that pool. Or PGW can use the help of some external network, and then it can get the IP address for the user. But it doesn't matter. Essentially, PGW will convey that IP address to the MME, and MME will forward that IP address to the user as part of the attach accept message. And of course, when you release the default bearer, then we have to release the IP address associated with that. Another way to allocate an IP address is use the so-called DHCP approach, Dynamic Host Configuration Protocol, DHCP. So in that case, our UE sends a message, DHCP discover message, and it says, oh, I need an IP address. So our serving gateway will forward that to the PGW, and the PGW could use the help of some sort of server, or it can act like a DHCP server. It depends on the capabilities of the PGW. But PGW itself could say that, okay, let me pretend that I am the DHCP server, and then it can offer some IP address in the DHCP offer message. Let's say A, B, C, D. So that IP address is now given to the UE. UE says, oh, yes, I would like to get that IP address. So it will make a request for that IP address, A, B, C, D, and the server sends the acknowledgement. Okay, so now we have reserved that IP address for the user. So this is how our UE can get the IP address using the DHCP approach. It is possible that we have multiple packet data networks. So one PGW could take care of multiple PGWs, or one PGW can control just a single PDM, just depends. And now we could get multiple IP addresses. So it's possible that this PGW says, okay, here is the IP address for user A, B, C, D. Another PGW says, okay, I will give another IP address, maybe E, F, G, H, or whatever. So it is possible that the user has multiple IP addresses because you can connect to multiple PGWs. So maybe this may be blackberry.net. Okay, so we will get one IP address, let's say, from BlackBerry server. And then if we are Verizon wireless subscriber or AT&T subscriber, then we would have another IP address from our own access point name. So in this case, we got two IP addresses. Oh, PDN, okay, PGW is PDN gateway, packet data network. And internet is one example of packet data network. So there could be any packet data network, maybe Verizon network, AT&T network, or just the regular public internet. So one PGW, one gateway, takes care of one or more packet data network. So one PGW controls, or not controls, but rather takes care of one or more packet data networks. So hopefully that is now clear, but if you want additional information or clarity, just let me know. Okay. A question is coming your way. Please give me your answer. I will give you 2-3 minutes to work on this. And when we say that we have bearer, this kind of default bearer or something like that, yes, it means that we are able to exchange user traffic. That is correct. One minute to go, but please participate in the poll. And we are looking for a true statement, not false. True statement. Thirty seconds. Okay, let's share the results. The first one is the correct answer. That we could give the IP address during the default bearer or after the default bearer activation. Now, all the other statements, right, they're false. For example, in LT, we support both dynamic and static. We do not say that only dynamic is supported. We support dynamic and static both, so we cannot choose that. Support for IPv4 mandatory? No. The standard says that UE can support maybe only IPv6. Okay. IPv6 mandatory? No. Maybe UE will support only IPv4. Dual stack IPv4, IPv6. Again, optional. So IPv4, IPv6, IPv4v6. None of the options is mandatory. So the UE could support one of these options. So it's not mandatory that a UE has to support a specific type of IP. Okay, we had one question regarding what is this dual stack IP for IPv6. So we had that question. So let me briefly talk about that. So basically, we have at the IP layer we have two options. Right? We could use IPv4 or we could use IPv6. So basically we have TCP layer, right? Then we have IP layer, then we have other lower layers here. Application layer. So these are 5 layers in Internet protocol stack. So for this IP we have two options, IPv4 and IPv6. So when we say that we have dual stack IPv4, IPv6, we have IPv4, we have IPv6, and on the top TCP and application. And layer 1, layer 2. So our device is able to support both IPv4 and IPv6 at the same time. So we could get both the addresses. So the network could give us two IP addresses, one IPv4 and one IPv6. And depending on the application and so on, we can choose the IPv6. Maybe some services will use IPv6, so then we will use IPv6 address. Some services, let's say so far we have been using IPv4. So for those traditional services, maybe our email, web browsing or whatever, we will use IPv4. But maybe in future there will be some new services, maybe high definition video streaming, and now those streaming servers, maybe they are IPv6 servers, and our dual stack UE can then exploit that IPv6, right? And then we don't need to do the IPv4 so for that server. So we are now getting flexibility. Okay. So that's what we mean by dual stack. We support both at the same time. Okay. So at the same time, we can talk to two different servers with two different IP addresses. One IPv4 address, another maybe IPv6. So hopefully this is adequate, but if you want more, we can discuss more. Okay. Okay, perfect time for a 10-minute break. And once we come back, we'll again unmute the bridge so that you have one more opportunity to ask the questions using the